Rogers, what is happening?
I don't know, boss. It's all blowing up.
Did you run the tests?
Yes.
All of them?
Yes. I did graph-based testing, ISP, GAC, CAC, and RAC. The whole thing.
Come with me. I want to show you something. This is a security testing facility. It's about time that you learned how we defend against the attackers. Security testing looks for faults that could be potential vulnerabilities to our system. So, while we've been looking at any sort of fault that could result in unexpected behavior, like this mutated for loop here, security testing is more concerned with faults that someone could actually use to attack our system, like this unguarded buffer situation here.
What's an unguarded buffer?
It's actually the most common type of vulnerability. A buffer is some sort of container in memory that holds onto strings, and if we're getting input from a user into one of these, we typically want to have some sort of guard that says you cannot write any more characters than this many. But sometimes we forget to do this, resulting in an unguarded buffer, allowing the user to just write as many characters as they want, overwriting other memory that's right next to the buffer. And typically this allows them to overwrite the return address of whatever function that buffer is in, allowing the code to now jump to whatever code section they have, which is usually a virus, of course. And so the main goal of security testing is to find out when these vulnerabilities exist so that we can write our software in a more secure way. And just like other kinds of software testing, this process is never complete. We can always find more vulnerabilities, and we can never assume that the system is 100% secure. So we are going to be talking about two of the most important areas of security testing, vulnerability scanning and penetration testing. The difference is that vulnerability scanning is typically done by automated software, while penetration testing requires the expertise and ingenuity of a human tester. A vulnerability scanner is a program that looks for vulnerabilities in your code and then tries to exploit them. So yes, these programs are actually dangerous, and as a result, we don't tend to run these on, say, a live website. As you may know, it's typically bad testing practice to destroy the system that you are trying to test. There are two levels that we can test at, the authenticated level and the unauthenticated level. At the authenticated level, we can test what a user can do from inside the system, such as if we wanted to take down UVA Colab from the inside. But the unauthenticated level tests the system against whoever shows up. So if we want to take down Virginia Tech's Hokey Spa, maybe we'll test that. So who uses these vulnerability scanners? Well, obviously just software testers. I mean, who else would want a piece of software that finds vulnerabilities in your code? Oh, that's right, hackers. It's ironic that hackers often use some of the same tools that we use for defense. So there's many types of vulnerability scanners, each made for the various types of systems to be tested. Why don't we take a look at a few web application security scanners? As you can see, there are a lot of web vulnerability scanners available, some of which are free and open source, while others are commercial and actually fairly expensive. Each scanner can identify a wide variety of vulnerabilities. For instance, if we go to the GitHub repo for the Tydos framework, we can see a list of common vulnerabilities that they cover. For instance, we have SQL injection and cross-site scripting attacks, both of which are very common, and lots more. And then we have penetration testing, also known as pen testing, ethical hacking, and white hat hacking. The idea here is to hire actual people to think like the attacker and find vulnerabilities before someone else does. Since the testers are actual human beings that are experts in their field, this option is usually a lot more expensive than vulnerability scanning. Pen testers use a variety of software tools to help them hack into the system. Typically, they actually use the same tools as black hat hackers. Why? Well, first of all, they're pretty available and often well documented, but also using these tools helps the testers better understand how they work and how to defend against them. So there's several strategies that pen testers use during testing. Just like we learned in class, we have black box and white box testing, and just like we discussed with authenticated and unauthenticated testing, they can focus on the interior or exterior of the system. Targeted testing is where pen testers actually work with the IT team, which is sometimes called a lights-on approach because everyone can see what's going on. This does not always happen because we also have blind testing, where the tester knows very little about the software other than like the company name, and double-blind testing, where very few people at all know about the test. This is typically used to measure a company's response to threats like this. Now you're probably thinking, this doesn't really sound like the other types of testing that we learned. Well, does it? Does security testing have, say, coverage criteria? Well, of course it does. But instead of worrying about covering all of the areas of code, we may be more concerned with covering the more vulnerable parts of the code. And how does security testing fit in with other kinds of software testing? Well, it's a kind of non-functional software testing, which, if you recall, tests attributes about the software behind the scenes, such as its security, reliability, etc. And finally, the most important thing to know about security testing is...
We're sorry, but this program has been canceled. Thank you for your support.